Alright, so this video is going to be how to graph the original function from a derivative function. I find this really helpful for a lot of questions, even if it doesn't ask specifically you to do this. I feel like it helps me with some of the free response questions, and then a lot of like concavity, this and that of the original graph, okay? So I'm going to start with this, and then I'm going to just make up some like area figures, okay? So let's say this is like an area of 6, and this is an area of 4, and this is an area of 2. This is a negative area because it's like under the x coordinate, or the x-axis, but I'm just kind of stressing that. Alright, this is how I start. So I got everything all set up for me. So first, if this is the derivative graph, where the derivative hits 0 is going to be my max and mins for my original graph. So my max here is going to be at a 4, right? So it's like positive and then negative derivative, which is really slope. Derivative is slope. So I got positive slope, I got negative slope. That means this went up and then down. So this is a local max of some sort. How high does it go? It goes up. Look, the area is 6. This goes up all the way to, I'm going to call this, does that look like right? Okay, I'm going to call that a 6, okay? So it goes all the way up to 6, assuming it starts at 0, 0. You know, maybe the start is 100, so that would be like 106 at 4 minutes or whatever. Okay, and then I go to my 7. At 7, I have a min. Where exactly is my min? Is it under here? Is it over? Okay, it is 6 minus 4, which is 2. 2 is like here. So here's 2. So 7, comma 2. That is my min. And then right here it hits at 9 again. So 9. Okay, so is it up here, down here? Let's see, I have 6 minus 4, which is 2, plus 2. So if I add up all my areas all the way to the 9, I have 4. 4 is right here. So 4, 9, comma 4, right there. Okay, so it goes up. I'm going to use a pencil for this. It goes up to 4, down to 7, up to 9. All right, now I'm going to do my concavity because that's not what an original graph looks like. It's some sort of concavity going on too. So my concavity is going to come from my highs and lows, my maxes and mins from my derivative graph. So at 2, concavity is going to change. 5.5 approximately, concavity is going to change. And at 8, concavity is going to change. Okay, how does the concavity change? I can kind of tell looking at it, but I'm going to go real specific, okay? So this is positive slope. Okay, positive slope, slope is derivative. So the slope of my first derivative is going to be my second derivative. What is the second derivative? Concavity. So positive slope here means concave up here. So really, this is what my graph looks like. It's concave up until here, and then it's concave down until 5.5. So concave down until 5.5. So like it goes like this. See how it's concave down, and then it's still concave down like that until I get to 5.5, and then it's concave up until I get to the 8. So concave up until I get to the 8. So something like this. And then it's concave down past the 9. So concave down, something like that. So I know there's like this straight line in the way, but it's concave up and then down and then up and then down, right? This concave down. All right, so this is one of them. I'm just going to do one more. If you want, you can skip to the end, and then I give you one to try, okay? So here's the first one. And then, oops, I'm like mixing up all my papers. Okay, and then my second one. So my second one looks like this. And again, I'm going to make up some numbers, okay? So sometimes you can find them yourself if they're like half circles and triangles and stuff, and you'll do that on your own, actually, in the next problem. But this one I'm just going to make up again. So let's say this is a 2, and this is a positive 3, and this is also a 2. It might not look the same, but I just made these up, right? So whatevers. Okay. So again, I start with my zeros. So starting with my zeros, I know that at 3, I have a max or a min, and this must be a min because it's a negative slope to a positive slope. Derivative means slope. So this must be a min. So a min, where's my min? Oh, it's at negative 2. That's a negative 2. 1, 2, something like that. Negative 2. So at 3, I'm at negative 2. And then at 8, I am, negative 2 plus 3 is 1. So at 8, I am at 1. There's my 1, okay? And then it hits one more time at 12. At 12, let's see. Negative 2 plus 3 minus 2 is negative 1. So at 12, I'm at negative 1, something like this. Okay, I'm going to draw first. So I go down, and then I go up, and then I go down. And then does it keep going? Yeah. This has a positive, I'm going to make it up, I don't know, 0.5. Okay? So it goes up. So like here, something like that. Okay. So now I deal with my, oh no, I did that in pen, darn it, that's okay. And now I'm going to deal with my concavity. So concavity is highs and lows here are going to be my concavity. So 2, point of inflection. 6, point of inflection. 10, point of inflection, right there. And then, I don't know what that is. Okay, so slope is negative, concave down. Slope is positive until x equals 6 or t equals 6 or whatever. So concave up until the 6. Up until the 6. I'm hitting all my points still, but now I'm concave up. I'm facing up. Alright, concave down until the 10. So concave down until the 10, and then concave up until 13. Alright, concave up until 13. So ignore the red, but the pencil marks are what my graph of f look like. Okay, so that was the second one. Now you try one. You try this one right here. You're going to pause the video, like now. I'm going to pause it. Okay. And then, all right, that was basically this, right? So you find like the areas. So you find the area, you find the area, you find the area. I think this is right. 1/2, 5 times 3 is 7.5. And then half of a circle with a radius of 2 is pi r squared divided by 2. And then a triangle here is 3 by 1. So 1/2, 3 times 1. Okay, so I think that's right. And if that's right, this is what your final result looks like. So yeah, hopefully that's right. Good luck. Okay? The end. Good luck.